In this tutorial session, we're going to look at organic chemistry, and our focus will be electrophilic substitution of benzene. So we are simply going to tackle the reactions involving electrophilic substitution of benzene. So our key objective here will be understanding the term electrophilic substitution of benzene by trying to understand some key chemical reactions and also learn the conditions and the products which are produced in this electrophilic substitution of benzene. So the reactions which we are going to cover in this tutorial session will be nitration of benzene, sulfonation of benzene, halogenation of benzene, Friedel alkylation of benzene, and also the Friedel acylation. So let's get into it as we propound this concept. Alright, so as I mentioned earlier, we are looking at electrophilic substitution of benzene. Before we can delve any further, let's try to understand what they simply mean when they say electrophilic substitution of benzene. So electrophilic substitution of benzene is simply a type of reaction in which an electrophile, which is an electron-loving species, replaces a hydrogen atom on the benzene ring. But once it replaces this hydrogen atom on the benzene ring, the aromatic stability of this benzene is just restored. Okay, so we are saying it is a type of reaction. So this is a type of reaction it's a type of a reaction in which an electrophile replaces a hydrogen atom on the benzene ring. So as I mentioned to say, the aromaticity or the aromatic stability of this benzene ring is restored. So aromatic stability of benzene is restored. Okay, so let's just look at a general reaction. So we have a benzene ring like that. The formula for benzene, the chemical formula is C6H5, then plus an electrophile. So this electrophile, one thing we should know about it is that it is an electron-loving species. So that's the difference between an electrophile and a nucleophile. A nucleophile it is a certain compound which is rich in electrons. But when you're talking about an electrophile, this electrophile, it is deficient of electron. Because it is deficient in electrons, it loves electrons. So we say it is an electron loving species, or an electron loving substance. So the benzene ring reacting with an electrophile, what is going to be formed is that to be this benzene, the hydrogen will be substituted, but the electrophilic substitution of this benzene will later be restored. So we're just going to have the benzene attached to the electrophile, then the hydrogen ion, but later it is then brought back. It is actually, there will be a reaction which is going to occur, the deprotonation of hydrogen, so that the double bond can be restored back. And in that case, the electrophilic stability of this benzene ring will now be restored. So if we are to write it using this structure, so we have a structure of benzene, then plus an electrophile. So what it's going to form is that we are going to have this benzene ring, then attached to an electrophile. So this is basically the reaction we are talking about, electrophilic substitution of benzene. And one thing we need to understand about this reaction is that the benzene contains these pi electrons which are delocalized. So there is a delocalized pi electron system above this and this chain, above and below this compound, which is benzene. And it is due to these electrons, or this electron rich that are in density, that it is able to attract these electrophiles, which are positively charged or electron deficient species. So these pi electrons, because they are delocalized, they are able to attract these electrophiles. So that is the simple concept which we must understand there. Right, so let's look at now these reactions, or electrophilic substitution reactions of benzene. So the first one which we are going to start with will be nitration. So now the types of electrophilic substitution of benzene. So the first one, we are looking at nitration of benzene. So we've done a video on these types of electrophilic substitution of benzene individually. By looking at nitration, there's a video on nitration, so you can just check on it. But in this case, we are trying to look at them generally, and we are doing them collectively. So when you're talking about nitration of benzene, you are simply referring to a reaction where the electrophile, the nitrite, is able to react with the benzene ring. Okay, so it is just simply a reaction where we have a benzene C6 H5 plus this nitric acid, then forming C5 so we have C6H6 plus benzene plus that nitric acid forming C6H5NO2 plus water. So one thing we must understand here is that this nitric acid, for it to react with benzene in this electrophilic substitution of benzene, nitric acid first has to undergo what is known as formation of an electrophile. So nitric acid in that case reacts with another acid, which is simply sulfuric acid. Then after it reacts with sulfuric acid, there is protonation. Nitric acid is protonated, so it will attract one hydrogen from this sulfuric acid. Once it attracts that hydrogen, it is able to form water. So now that water will leave as a leaving group. Once the water leaves, then we are able to form now NO2 plus, which is an electrophile in this process of nitration. Then this electrophile which is formed, since it is our main interest in this reaction, it is able now to react with the benzene, thereby forming this compound, which is benzene attached to a nitrite. So this is the general reaction which takes place. So when this happens, so we have our benzene in this case, then this benzene reacting with this electrophile like that. So the reaction which occur will be nitration. Then we are going to form this structure. Okay, so this is the general reaction format. Then of course you're going to produce sulfuric acid and also the water, which will be part of the products or the byproducts, right? So this compound which is formed is what is referred to as a nitrobenzene. Okay, so this is a nitrobenzene. Then let's look at the conditions under which this reaction can be successful. So when you're talking about the conditions, you're referring to the reagent which must be present, and also the temperature which must be moderated so that this reaction comes to the completion. So the first thing, it is there has to be the presence of nitric acid. As I mentioned earlier, to say that this nitric acid react with the sulfuric acid. So another thing or another reagent which must be there, it is the presence of the sulfuric acid. And we should take note that the nitric acid and the sulfuric acid must be concentrated. So just indicate in brackets to say Kong. So they must be concentrated, and the temperature under which this reaction can be successful should be moderated in the range of 50 to 60 degrees Celsius. So the temperature is 50 degrees to 60 degrees Celsius. So if you are able to moderate this temperature, then you are able to form this reaction, which is nitration. So the nitration reaction is able to take place if you take note of these conditions. So as I mentioned, the nitric acid, which is able to react with the sulfuric acid, the sulfuric acid in this case, it just plays a role to produce the electrophile, and this electrophile is what we call the nitronium ion. So this NO2 plus, it is simply the nitronium ion. Nitronium, the nitronium ion, and now we are able to form this product, which is a nitrobenzene. So this is actually the first reaction under electrophilic substitution of benzene. Let's look at the second reaction. So the second reaction you're going to look at is sulfonation of benzene. So under sulfonation of benzene, we are simply reacting this benzene with sulfuric acid. It is also an electrophilic substitution. So we have benzene there, then reacting with sulfuric acid, then we are able to form the product C6H5 SO3H, then of course plus water. Now how this reaction take place is that the first thing, you react to sulfuric acid. Sulfuric acid react with another sulfuric acid. Then in that case, one sulfuric acid will be protonated. Once it is protonated, the water is able to leave. Then once the water leaves, you're going to have a certain electrophile which is going to be formed. So once you produce that electrophile, which is just SO3 plus, SO3 plus with hydrogen like that. Yeah, so we're able to produce this electrophile. Then this electrophile will now be able to react with the benzene, therefore forming the product, which is the benzene sulfonic acid. So this is the general reaction. So when you have the benzene like that, it reacts with the electrophile, which is this electrophile. The double bond attack this electrophile, then you're able to form a reaction of that kind, of course with SO3 plus, then plus the water, which is just a byproduct. So this product which is formed is what is known as benzene sulfonic acid. So this is benzene sulfonic acid. So this is how this reaction is able to take place. We've also made a video about sulfonation of benzene. You can just check it out on this channel, where now we are describing the reaction mechanism and how it comes about. So now let's look at the conditions which must be maintained. So the conditions of sulfonation So as I mentioned earlier, there has to be the presence of sulfuric acid. So we are going to say fuming sulfuric acid, fuming sulfuric acid, which is oleum with sulfuric acid, like that, then plus SO3, like that. Okay, so this is one condition. The other one is that there has to be concentrated sulfuric acid. Then the other thing which must be there is that the temperature must be moderated about so the temperature must be moderated around 40 degrees, approximately 40 degrees to somewhere 80 degrees Celsius. Then that reaction will be able to take place. Okay, so that is about sulfonation. Let's look at another reaction which benzene is able to undergo. So the other reaction is known as halogenation. So as the name itself suggests, it is an electrophilic substitution involving the reaction of benzene with a halogen. So that is simply halogenation of benzene. So with this halogenation of benzene, we are reacting the benzene. We are reacting the benzene with a halogen, let's say a chlorine. Then we're able to form a product which is known as chlorobenzene. So C6H5, then Cl plus HCl, like that. So this product is the one we are calling chlorobenzene. Then the conditions which has to be maintained for this reaction to take place are that there has to be the presence of a chlorine gas, of course, a halogen, should I say. So there has to be a halogen. In this case, we used chlorine gas. Then, other than that, there must be a Lewis catalyst. So the Lewis catalyst we have, it's there has to be an ion bonded to a certain halogen, for example iron chloride. Then also we should have aluminium chloride. So we can choose between these two. We can use iron chloride or aluminium chloride. Then the reaction takes place at room temperature. At room temperature and pressure, and that is approximately around 25 degrees Celsius room temperature. So this is about halogenation. So you can just look at how the general reaction takes place. So we have a benzene ring, then it is going to react with the double bond there attacks one chloride, then that is able to leave. Then you'll be able to form this compound, which is a chlorobenzene, then with other products. Okay, so this is how this reaction is able to occur. Then we're also going to look at another reaction, let's say with the bromine, so which is known as bromination. So with bromination, we're still looking at halogenation. We can have the benzene ring reacting with a bromine like that. Then this double bond attacks. This one is going to leave. Then you form a product of that kind with a bromine like that. Okay, so that is under bromination. So for this one, we're going to say the conditions will be there has to be the presence of bromine gas. Okay, other than that, there has to be iron 3 bromide. Then this iron 3 bromide will act as a catalyst. Okay, that is one thing we must understand there. Then we'll also look at another reaction. So this would be reaction 4, which is known as a Friedel-Crafts alkylation. So under Friedel-Crafts alkylation, you are simply introducing an alkyl group onto the benzene ring. So how this reaction is able to take place is we have a benzene ring like that. So we have a benzene ring. Okay, let me start with the chemical reaction. So C6H6, then it is able to react with an alkyl. An alkyl is simply an alkyl chain, then bonded to, since we are talking about alkylation, so to be an arrow group bonded to a halogen. So this is what you're going to form: C6H5, then with an alkyl, then plus HCl. So the product you're able to form there, it is the one we are calling an alkyl benzene. Okay, so let's say, for instance, we had to react this benzene with a certain alkyl group, let's say a methyl chloride. So what is going to be formed here? We are going to have a benzene ring, then bonded to that alkyl group, which is a methyl. Then we're able to form hydrochloric acid as a byproduct. Let's look at the reaction in form of structures. So we have this benzene ring reacting with an alkyl group. I'll just write it in this manner. So that is how the reaction occurs. Then you're able to form benzene ring attached to this alkyl group, then plus the hydrochloric acid as a byproduct. Okay. Okay, so this is what we have. Then we've said the product which it forms, which is this one, is simply an alkyl benzene. So this is the product which is formed. So in this case, let's say we had to react with a methyl chloride. Okay, let's take an example whereby we reacted with this benzene Then we have to react it with a methyl chloride. Then this reaction has to occur in this manner, where we have now the benzene ring attached to this methyl, of course with HCl like that. So this compound, which is formed here, is a methyl benzene. And when you have a methyl benzene, it has a chemical name which is also known as a taurine. So taurine is simply a methyl benzene in chemical terms. So this is the products which it forms. Then when you're talking about the conditions which must be satisfied for this reaction to be successful, of course the first condition will be there has to be a presence of this alkyl halide. So there has to be an alkyl halide, an alkyl group attached to a certain halogen. So we're going to say maybe an alkyl group attached to a chloride, or maybe you have an alkyl group attached to a bromide, yeah, or something like that. Then when you're talking about the other catalysts, the catalyst which must be present in this reaction, it is simply anhydrous aluminum chloride. So you must have anhydrous aluminum chloride. Then the other thing which must be there, there has to be a dry condition. So there has to be a dry condition. Then we know that there will be obviously a carbocation which is going to be formed in that manner, like a methyl, then with a positive charge. Then this methyl is what is being attacked by the double bond. Okay, so we must understand that. Then the last reaction we are going to talk about will be Friedel acylation. Friedel acylation. So under this Friedel acylation, we are simply introducing an acyl group onto the benzene. So we are introducing an acyl group. When you're talking about an acyl group is simply this group, our group, with a ketone like that. Okay, that is an acyl group. It is just an alkyl group bonded to a certain ketone. Then we are introducing it onto the benzene. So how this reaction is able to take place, we have a benzene ring, then there will be this acyl group rather. So we'll have an acyl group. This is an alkyl group bonded to a certain carbonyl group, which is a C with a double bond on oxygen, C double bond with oxygen. Then we have a certain halogen attached also. So when that happens, we call it an acyl group. So it is an arrow group with a carbonyl group. Then this carbonyl group is further attached to a certain halogen. We can call it maybe chlorine or bromine. Then the products which we are going to form will be an aromatic ketone. So we are going to have this kind of products, C6, which is a benzene, C6H5, then with CO R plus, of course, the hydrochloric acid. So that is what happens there. So this product, we call it just an aromatic ketone. Okay, then if we are to show it using chemical structures, so it will be a reaction which is going to take place in this manner. So we have a benzene ring like that, then it reacts with a certain alkyl group. So let's say it is a methyl, okay, bonded to this group, carbonyl group, then with a chloride there. Or I can write it in this structural manner. So we have this, we have now, okay, so we have this, then this is an alkyl group bonded to this carbonyl group like that. Then this carbonyl group is bonded to a certain halogen. So this is what we have. So what happens here is that there will be a reaction which is going to be taking place where this double bond is able to attack the carbonyl group. Then of course there will be the displacement of this double bond. The electrons will be pushed to oxygen. Then once that happens, we are going to form a compound of such kind. So it will be bonded to a certain carbonyl group like that. So we're going to have a reaction in that manner. We're going to have that. Then this will be bonded to a certain chain. An alkyl, bromine, then we have an alkyl. So we're going to have this as our product, which is simply an acetophenol. We call it an acetophenone, because we have an acetyl group bonded to this phenol group, which is a benzene ring. Then we have a double bond there, which is a carbonyl group there, which is just a phenol. Which is simply a ketone rather. Okay, so this is the product which we are forming, an acetophenol. Okay, so this is how this reaction is able to take place. Then when you're talking about the conditions which must be satisfied for this reaction to occur, the conditions are that the first thing, you must have an acyl group. So you must have an acyl group. So this acyl group is simply an alkyl group bonded to a certain carbonyl group. Then we have also an halogen attached. Then we must have also anhydrous aluminum chloride. So anhydrous aluminum chloride like that. which will be acting as a catalyst. Then other than that, there has to be a dry condition for this reaction to take place. And we know that we have an electrophile, and what acts as an electrophile is simply what acts as an electrophile is simply this acyl ion, and we've said that the acyl ion is simply just another group bonded to this carbonyl group with a positive charge like that. That is an acyl ion which is attacked by this benzene, this benzene ring, the double bond on the benzene, or the pi bond rather. So this is it about the electrophilic substitution of benzene. If you found this to be helpful, please don't forget to like, subscribe, and also share. You can also feel free to subscribe to our app, Meticulous Study Hub, and also the channel Meticulous Hub. Also have a website, Meticulous Study Hub website, where we have A-level natural sciences and also second year courses, including the IGCSE International Cambridge courses, the study materials for junior, senior secondary. You can just contact the number which is displayed, then you have access to the app, or you can email us using the email address there. Thank you for watching.